everybody. Today we're going to continue our work with fractions, and today we're going to be taking a look at how we can decompose unit fractions, so break apart unit fractions like 1/4, 1/8, 1/6, using an area model to start and look at equivalent fractions. Okay? So today we're going to start with an area model that shows 5 equal parts. So if I were to ask you to draw an area model and partition it into 5 equal parts, you would do something like this. 1, 2, 3, 4. There is an area model, right? We've got a rectangle and we've broken it into 5 equal parts, or fifths. If I shade 1/5 here, I can write that I have 1/5 shaded, right? So if I decide to take a horizontal line, I'm going to make it blue, and go like this, okay? How many parts do I have now? So check how many pieces I have now. I had 5, and then I put a horizontal line all the way across. And I basically took each one of those fifths and broke them in half, right? So now we have the unit fraction of 1/10, or tenths, right? Because we have 10 equal parts. How many tenths are shaded? Here's 1/10, and here's another 10th. So we've just discovered that 1/5 is equal to 1/10 plus 1/10. Or we can say 1/5 is equal to 2/10. Or we could even write it as 1/5 is equal to 2 times 1/10. Any of those number sentences is true, right? Because the shaded part of our fraction did not change, right? We started with fifths, and then all we did is put another line to break it up a little bit more, but we didn't change the section that was shaded, okay? So we've discovered that 1/5 is equal to 2/10 simply by drawing an area model and then breaking it up into some smaller parts, okay? Now let's take a look at another one. Let's see if we have one that's partitioned into thirds. And when you're doing this, you may not have different colors to draw your lines, so you can use dotted lines. I'll model that for this one. So let's say we've got an area model broken into thirds. We know that each one of these parts is 1/3, right? What if I asked you to try and figure out how I could break this apart to compare 1/3 to 4/12? I want to compare 1/3 to 4/12, and I want to see if they are equal or not. So how can I break up those thirds even more to make 4/12? So you might say, hey, I could break each of these up this way, right? Going down, and you can. But if we're thinking about an area model, you might want to think about, if you know, I'm going to make a smaller version, this side is 3, right? Because you've got 1, 2, 3. 3 times what makes 12? 4, right? So if I break up my lines, my spots, into 4 equal parts going across, I now have 12ths shown, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See how I have 12ths shown? I think it's hard with my dotted lines. I'm wondering if it's just easier if I use color. You will use dotted lines, but if I show it like this, it's kind of easier to see the 12 parts. You see how we have 12 parts? If I shade 1/3, now that I've partitioned my area model not only into thirds but also into 12ths, how many 12ths are highlighted? Well, here's 1/12, here's another 12th, here's another 12th, and here's another 12th, right? So 1/3 is equal to 1/12 plus 1/12 plus 1/12 plus 1/12, right? And is that the same as 4/12? Well, yeah. 1/3 is indeed equal to 4/12. I can also write it as 1/3 is equal to 4 times 1/12, because I have 4 of those 1/12 in the area model. Okay, let's take a look at one more example. What if you start with 1/2? So let's make an area model, split it in half. I like to label down on the bottom so I remember what I'm working with. And what if I want to have you compare it to 5/10? What if I want you to check, is 1/2 equal to 5/10? How could I take my current area model and break it up even more so that I now have tenths? Well, I know 2 times 5 is 10, and I have 2 parts going across, so if I have 5 parts going down, that's going to make tenths. So I'm going to think about how to make it in tenths, and I'm going to do 1, 2, 3, 4, and check if I've got 5 equal parts now. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I meant 10 equal parts, guys, sorry. 5 on each side. So now I have tenths, right? If I shade 1/2, there's my 1/2 shaded, and I compare it, do I also have 5/10 shaded? Well, let's see. Each one of these is a tenth. 1, 2, 3, 4, 5/10. So sure enough, 1/2 is equal to 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10, or 1/2 is equal to 5 times 1/10, or 5/10. So your job today in the assignment is to take some pre-drawn area models and partition them out a little bit more to search for some equivalencies and find the equivalent fraction. And then you're going to be asked to draw your own area models. So make sure you understand what I'm asking you to do. Let me know if you need any help, and